So far we learned if we have a discrete random variable, we can form the frequency table, and the relative frequency basically gives us the probability for that random variable. Now I expect you to ask how to find the mean, standard deviation, and variance in this case. So we're going to erase this part of the board. We're going to keep the table. We need the table. And one by one, I show you how to find each one of these. To find the mean of your data, it's not that difficult. Let me show you. To find the center, or in this case, the mean, what are you going to do? You're going to take each x, multiply that by the probability of that x, and then add them all together. Mathematically, we write it as sigma x times p of x. What's the meaning of that? It means that in this case, I'm going to take the first x, which is 0, multiply that by its probability, which is 23.7%. Then I go to the next variable, which is 1, multiply that by its probability, which is 41.2%. Then I'm going to go to the next variable, which is 2, and multiply that by its probability, which is 21.1%. Then I'm going to the next variable 3 and multiply that by its probability, which is 8.8%. Then I'm going to go to the next variable, which is 4, multiply that by its probability, 3.5%. And my last variable is 5. I'm going to multiply that by its probability, 1.8%. If you do this, you get the mean 1.3. So the average score for the employees, or the households having computers is 1.3. If you round this, you get about 1. So you have about 1 computer per household as a typical number of computers. So if somebody asks you, hey, what is the typical number of computers in American households? Your answer is 1. So you expect that the average or the center or the balancing point be 1. Now that we found the average or the mean, we're interested in knowing what is the standard deviation. So I'm going to leave the formula for the mean here, and that we found it as 1.3. To find the standard deviation, what are you going to do? You're going to create the rest of these columns. You need to have the variation from the mean. So you're going to continue this column. You're going to create x minus the mean. We already calculated the mean. Mean is 1.3. So I'm going to write this guy down up here. Mu is equal to the sum x times p of x, and we found the mean for that example, which is 1.3. So what's the meaning of that? It means that we need to take each x in the first one, in the first row, the x is 0. 0 minus mean, we calculated mean 1.3. Then we go to the next x value, which is 1. 1 minus 1.3. Then we go to the next x value, 2 minus 1.3. The next x value, 3 minus 1.3. 4 minus 1.3, and 5 minus 1.3. And we need to do the computation here. We have some algebra, all right? After calculating this, you're going to create the next column. In your next column, you're going to take x minus mean and raise it to the second power. So with another format, x minus mu squared. So here, you're going to find x minus the mean and raise it to the second power. So each numbers here will be raised to the second power, or x minus mu to the second power. So let us do this, do each one of these. 1.76. This number raised to second power is 0.11. I'm rounding everything. Then this number raised to second power is going to be 0.45. This number raised to second power, 2.80. This number raised to second power, 7.14. This number raised to second power, 13.48. After that, after doing all these computations, you're going to multiply each one of these numbers by its probability. So you're going to multiply 1.7 by 23.7%, 0.11 by 41.2%, and so on. So you're going to form the next column, which is px times x minus mu squared. So again, we're going to take the probability, 23.7%, and multiply that by 1.76. We're going to take 41% and multiply that by 0.11. The next probability is for variable 2. We have 21% multiplied by 0.45. 8.8% multiplied by 2.80. Then you have 3.5% multiplied by 7.14. You have 1.8% multiplied by 13.48. And in the last step, you're going to add all of these together. So you do the computation for these numbers. Let me write it down here as well, in case you want to see what's going on. Have the accurate numbers, almost accurate. So this is about 0.418. This is about 0.044. This is about 0.095. This is about 0.246. This is about 0.250. And this is about 0.243. Now add all of these together. Add them all. If you add these together, you get your sigma squared, which is your variance. The variance is equal to 1.296. But standard deviation, sigma, is the square root of variance. So the square root of 1.296 is about 1.1. We found the mean and we found the standard deviation, 1.1. So on average, we expect the US households have one computer with standard deviation about 1.